Hi everyone, so I'm back. We are doing 6.5 and here we go. So solving rational equations is similar to just solving equations. Obviously, it's again just a um, solving an equation, but instead of just simple problems like this, which is a multi-step equation, or this one, which is a two-step equation, or this, which are grade 9 material. Now it becomes a little bit more complicated. But really, if you would remember how um, solving equations was done in the previous grades, it is just a matter of doing the opposite. All right. So, for example, like this. As I get to this one, then I will talk about what I mean. All right. So as we solve this, the idea is to get the variables together and then isolate that variable, meaning get it to become just an x. If there's a coefficient, you have to get rid of that. Well, the number or the numbers have to be together on the other side. All right, so right now you have your x here and your x here. It really is up to you where you want your x's. You can bring this to the other side, or you can bring this to the other side. It doesn't matter which one. Me, force of habit, I would rather bring my x over to that side wherein I would have it positive right away. So if I'm going to move this 3x going here, that would become a negative 3x. So I don't want that because negative 3x plus 2x is negative x. So I would rather move this 2x over here, and that means I can do that by subtracting 2x from both sides. Okay. Now this cancels out. 2 is equal to x minus 4, and of course you add 4 to both sides, and x is 6. All right. Okay. So this is the one I'm talking about, which is a two-step equation, which is to just do the opposite. It would be the reverse of BEDMAS. So as you look at this, which is actually a lesson that I did in Math 9 today, there are two things happening in the question. The x here is divided by 4, and then there is addition of 3. So to do the opposite, it would be to subtract 3, and it would be to multiply by 4. All right. But then it would be the reverse of BEDMAS. So we will subtract 3 first. This cancels out. X over 4 equals 4. And then multiply both sides by 4. All right. So I will use a different color. Oops. So that you can see because I'm running out of space. So multiply by 4, multiply by 4. This 2 cancels out. X is 16. All right. While here, you would have to have a common denominator. The LCD for these two would be a 12, could be a 24, whatever, it's up to you. So to make this have a denominator of 12, you multiply the denominator by 4. The top is multiplied by 4, so you have 4m. To have this, or to get this, have to become a fraction with a denominator of 12, multiply um, the denominator by 3. All right. I want to get rid of that. Okay. So the top is multiplied by 3. This is 9m. All right. Is equal to 13. So the top can be put together now. All right. 13m over 12 equals 13. Right. Okay. So there's so many ways to do this. So it's up to you. I don't know how much facility you have with the math. So some kids would say, oh, Mr. Abrin, I would be multiplying both sides by 12. Now the question is why? So that these two cancels out, right? At the same time, you can divide both sides by 13 or multiply by 1 over 13, all right? 1. So you multiplied by 12 and then you multiplied by 1 over 13. All right, so, okay. Where do we put that? Okay, well, it's multiplied here by 1 over 13. All right, so the 13m here is equal to 13 times 12. All right, I just ran out of space. Okay, times 1 over 13. So these two cancels out. And then m is equal to, all right. Oh, these two cancels out also. M is equal to 12. All right. That's not too hard. You should be able to do that. Okay. So I will skip deconstruct your understanding. I will go straight into check understanding number 1. Solving rational equations with monomial denominators. So uh, we have this. As always, we need to figure out a common denominator. How can you put these two together? I think you can. It's as simple as just multiplying these two together. But guys, take a look. What if this is what I do? Since I don't just need to get these two together under one denominator, as I think about this question, I also have to think about what to do with the denominator in the other side of the equal sign. So what if I just multiply both sides by 10x, all right? Right? Now, look here. 10x would be multiplied to each one of these, all right? So that you don't have to have a denominator anymore. You know what I mean? So 10x times 1 divided by 2x is just a 5. So once again, if you're thinking, where did this 5 come from? This is the result of this 10x multiplied by 1 over 2x. That becomes 10x over 2x becomes a 5, all right? Minus 10x times 2 is 20x divided by 5 is 4x, all right? That's minus 4x equals these two cancels out, right? So be very careful about the algebra. Once again, it is really very simple, but if you're not careful, you will mess it up. So to get this negative 4x to be by itself, we need to subtract 5 from both sides, leaving you with this cancels out. Negative 4x is equal to negative 4. And obviously, to solve that, divide by negative 4. And the answer is 1. All right, x equals 1. Now, guys, it is always important for you to do the check part. All right, so just remember, this is the question. Let's see if we plug it in and if it works. Check. Okay, so the question was 1 over 2x minus 2 over 5 is equal to 1 over 10x. So if x is equal to 1, so let's see what's going to happen. This x is replaced by 1. It becomes a 2. 1 over 2 minus 2 over 5. Is that equal to 1 over 10? This x was replaced by 1 multiplied by 10. Okay. 1/2 minus 2/5, so the common denominator would be a 10. This 1/2 becomes 5 over 10. This 2/5 becomes 4 over 10. Is that the same as 1 over 10? And obviously, 5 over 10 minus 4 over 10 is equal to 1 over 10. And yes, it checks out. All right. Next one. Letter B. All right. So how do we get rid of the denominator here? So it would be nice to just work with an expression or an equation without a denominator. Okay. If I multiply everything by x, we will still have to deal with this square. So what if we multiply everything by x squared, right? Remember that x squared is going to be distributed here. So for the first one, x squared times 5 over x. If I multiply this by this, it becomes 5x squared over x, which is just 5x, right? Okay. While if I multiply x squared by 6 over x squared, it would be 6x squared over x squared. So actually the x squared cancels out, right? Is equal to 6x squared Oh, wait a minute. This looks like something that we have done before. All right. Look at this, guys. We have an exponent of 2, which means it's a quadratic equation. So remember how to solve quadratic equations. Get everything to one side and 0 on the other side. So let's bring these two over to this side because I want the 6x squared to be positive. All right. 0 equals 6x squared minus 5x minus 6. Are you with me? So what would that be? So I don't want to waste my time in doing decomposition. So some of you would have been able to figure it out in multiplying it in your head. It would be 3x here, 2x here, 3 here, 2 here. So if it was a negative, so this is what? Minus, this is plus, okay? 3x times 2x, 6x squared. 3x times negative 3, negative 9x. 2 times 2x, that's positive 4x, gives me negative 5x. 2 times negative 3 is negative 6. So we're good. Therefore, 3x plus 2 equals 0 because we're splitting it up into 2. 3x equals negative 2. X is equal to negative 2/3. 2x minus 3 is equal to 0. 2x is equal to 3. X is equal to 3 halves. All right? So guys, just take note. All solutions of equations should be verified. All right? In our text, you will notice that they're not really doing that anymore. Me, I only did that in the first example, but for letter B, I'm not going to do that anymore. Okay? So kindly do the practice work that I will give you on Google Classroom. Thanks for watching. Bye.